Topic 5.5. We'll be solving applications problems that use exponentials and logarithms. Okay, we want to find the H3O concentration of pure water, or should I say the hydronium ion concentration of pure water. The pH formula is pH equals negative common log of H3O. Now, the pH level of pure water is defined as 7. That equals the negative common log of the hydronium ion concentration. And now we need to solve for the H3O. So we need to get rid of the negative and then the logarithm. To get rid of the negative, we're going to multiply both sides by negative and get negative 7 equals the log of H3O. From here, we're going to use property number 1 to get rid of the logarithm, which says that we use the base of this logarithm, which is base 10, and this as a power, to equal the argument, or the inside of the logarithm. Okay, 10 to the negative 7. This simply means there will be a total of 6 zeros in front of the number 1. So 1, 2, 3, 4, 5, 6, and then the number 1. And that's the H3O concentration. Okay, number 5. Number 5, we want to double our investment of $10,000. So how many years would it take money to be compounded monthly at a rate of 9%? So, since we're compounding monthly, we need our compound interest formula, which is A equals P, and then 1 plus the rate divided by the compounding N to the power of N and T. Okay, so we have to find out what is A, what is P, what is the parameter R, what's the parameter N, and the parameter T. Let's get rid of this right here. Alright, so the amount was, say they wanted to double our investment of $10,000. So it actually means that the amount, given the principal is $10,000, we want to double that, will be $20,000. And the rate was 9%. Which is the same thing as saying 0.09. And the compounding is monthly. So monthly means we're compounded 12 times in a year. And we're looking for the time. Alright, so let's put everything in. So this will be 20,000 equals 10,000. 1 plus the rate, which is 0.09 divided by 12, all to the power of 12t. Okay, let's simplify this right here. So 1 plus 0.09 divided by 0.12. Okay, so 1 plus 0.09 divided by 0.12. Sorry, just 12. Which will give us 1.0075. So 0.0075 is the new base. And this will be 20,000 and 10,000. Alright, so it'll take us 4 steps. First, we need to eliminate this here, the coefficient 10,000, then the base, and then the 12. So 3 steps. So to eliminate the 10,000, I'm going to divide both sides by 10,000. And this will give us 2 equals 1.0075 12t. Now to get rid of the base, we'll use our property number 1, which means that this will be a log with the base of 1.0075 of 2 equals 12t. Now, our third step will be dividing both sides by 12. So divide this by 12. 12. Alright, so in order to solve this here, I'm going to take log base 10 of 2 and divide that by log base 10 of 1.0075. This is called the change of base formula. And all that divided by 12. Okay, this will give me an approximate time, let's see here, of 7.7 years. Okay. Good. All right. Next, how many years should your money be compounded weekly at a rate of 12% to double any investment? Okay, so we have A equals P R N T. Okay, and this is going to be compounded weekly. So we define A, P, R, N, and T. First, we want to double any investment. So it means that P is not given, so the original principal will remain P. The amount that we're trying to get out at the end will be 2 times P. So 2P and P. The rate will be 12%, which is 0.12. And the end, since we're compounding weekly, will be 52. And we want to find the number of years that it takes to make this happen. Okay. Alright, so what we have is 2P equals P, 1 plus 0.12 divided by 52 to the power of 52 and T. Alright, let's simplify this inside here and find our base. So this will be 1 plus 0.12 divided by 52. Okay, got a lot of decimals here. 1.0023. Okay, that's good. Alright, now we're going to get rid of the P, then the base, and then the 52. So first the P, we're going to divide everything by 2. Sorry, divide everything by P. That gives us 2 equals 1.0023 to the power of 52t. Then to get rid of the base here, we're going to convert this to a logarithm. So this will be a log with a base of 1.0023 of 2 equals 52t. Thirdly, we're going to divide by 52. And in order to take the log base 1.0023 of 2, we have to find what is the log base 10 of 2 and divide that by the log base 10 of 1.0023 and divide all that by 52. Okay, when we divide that, we're going to get just over 5 years, or should I say just under 6 years, 5.8 years. Number 8. How many years would it take to make 10 times your investment if it is compounded continuously at a rate of 12%? Compounded continuously means you have A equals P e to the RT. So we'll find A, P, R, So, our final amount, we're trying to see how long it takes to make 10 times your investment. While investment is represented as P, 10 times that amount will be 10P. The rate will be 12%, which we'll use 0.12, and we're looking for the time. Okay, so this will be 10P equals P e to the 0.12, and this will be T. Alright, to solve for T, we need to get rid of the P, the E, and the 0.12. First, let's get rid of the P. We're going to divide both sides by P, and we get 10 equals e to the 0.12 T power. From there, we're going to get rid of the e by rewriting this as log base e of 10 equals 0.12 T. And then lastly, to get rid of the 0.12, we're going to divide both sides by 0.12. So, this implies that log base e is the natural log of 10 divided by 0.12. Okay. And this will be approximately just a little over 19 years. So 19.2 years. Number 9. How many years would it take to become a millionaire by investing $2,500 compounded continuously at a rate of 12.5? So A equals P R E T. So A, P, R, N, T. Alright, the amount that we're trying to get. We want to be a millionaire. So that's $1 million. Our principal will invest $2,500. The rate will be 12.5%, or should I say 0.125. And time is what we're looking for. How long it takes to become a millionaire with $2,500. Okay, so this will be 1 million equals 2,500 e to the 0.125, and that's T. Alright, so it'll take 3 steps to solve for T. Removing the 2,500, removing the E, and removing the 0.125. Okay, let's divide everything by the 2,500 first. Let's see here. 25 goes into 100 4 times. That leaves these 4 decimals, or zeros. We cancel out 2 of those. We have 2 left. And this leaves e to the 0.125 and t. Okay, now from here, I'm going to get rid of the e by converting this into a log base e of 400 to equal 0.125 t. And then we'll divide both sides by the 0.125. Which will be the natural log of 400 all over 0.125, which equals the time. And this will be approximately 48 years. Let's put that into the calculator.